Okay, good day everyone. So in this video, what I'd like to do is cover a pretty basic feature that R has, and that's its ability to store information as objects. So for instance, in the console window here, we could create an object name. We'll just say X for simplicity, and we could have X here represent a number by just typing a little arrow like so, and then typing a number. So we'll just choose 1. And if we run this line of code, what you'll find is nothing in particular will happen. So we'll run it. You can see it got output to the console there. But besides that, nothing has really changed. However, if we run X as a line of code in its own right, like so, you can see it outputs a value of 1 there. So R is what's called an object-oriented programming language. And interestingly, if you look into how R actually stores what we've done here in memory, the object in this case is actually the number 1, and X is merely the name that we're assigning to that object. And I'm telling you this because a lot of R users are actually under the impression that the reverse is true. In other words, they're under the impression that we've, in some sense, created an object called X, and we've stored something inside of it. But that's not actually the case. X is just a name that is binded to the object 1, and this object 1 is located somewhere in your computer's memory. And admittedly, unless you're doing some seriously advanced R programming, this is a fact that is not going to matter to 99% of users. But I still think it's interesting nonetheless, because what it means is, in memory, if you were to do something like this, let's say you type Y arrow X and you run that. And then you take a look at what Y outputs. You can see Y outputs a 1 quite logically. But the kind of fascinating part about this is that Y and X here are quite literally the same object. That is to say, they're accessing the same chunk of memory. However, if we did something like this, like let's say we say A, and then we follow that with an arrow and then 1, we say B, arrow 1, and we run both of those, obviously A and B are going to output 1s in this case. But what's fascinating is even though they have the same numerical value, so that's the number 1 in both cases, it's represented by a different chunk of memory. So this number 1 is stored, at a different location in your computer's memory than this number 1. Now, if we were to do something like this, like let's say we modify Y. So if we type something like Y arrow Y plus 4, how about that? And we run that. Then we take a look at what Y outputs. You can see it outputs a 5, which makes sense. But what about X? We said that X and Y are the same object, but are they still the same object? So if we type X and we run that, you can see it outputs a 1. So what's happening here is that the names X and Y no longer reference the same chunk of memory. Basically, by modifying Y on line 12 here, we've created a new object in memory. So this new object is 5 here. So that's just some insight into how R kind of works under the hood. Now, to assign the object names, you'll notice we've been using this little arrow symbol. But what we could have done instead is we could have done something completely equivalent to this by just using an equal sign. So for instance, we could have typed, X equals 1, and this will do the exact same thing. So we can run that, and you can see it spits out a 1. Correspondingly, you could do that for Y and all of these other values. We could have just used an equal sign instead. So both the equal sign and the arrow symbol here, in the manner that we've kind of been using them, are what are referred to as assignment operators. And they're obviously called this because they're performing the operation of assigning a name to an object. And for most use cases, there's no practical difference between these two operators. I guess like the one main difference, would be the fact that you can actually flip the arrow around and assign objects to names. So for instance, you could type something like 10 arrow. Actually, we got to flip the arrow around, sorry. You could type 10 arrow, and notice this arrow is pointing the opposite direction to these ones. You could type 10 arrow Z, run that, and then you can see Z quite naturally outputs a 10 there. So the fact that we can use both the equal sign and the arrow here as assignment operators raises an obvious question. Which is better to use? And to be honest, this is a question for which there are many strong opinions. If you're asking me, I'd say the arrow is better. And the reason I say that is just because it does have a bit more functionality, though the nature of that functionality is a bit more advanced. And maybe in a later video, I'll kind of discuss it. That being said, I do have to admit, there is a kind of there's a kind of visual and intuitive appeal to using the equal sign. Plus, it corresponds nicely with other programming languages like Python. But I'm a firm believer that form should always follow function. So that's the reason I'm sticking with the arrow. It just has a bit more functionality, even if it is an advanced functionality that doesn't get used all that often. Now, if you opt to use the arrow, it's worth noting that RStudio has a keyboard shortcut that offers kind of a more ergonomic way of typing it. So if you type Alt minus sign in RStudio, it will automatically type the arrow there. So that's just a nice little feature. Let's maybe get rid of all this. Now, thus far, all of the objects we've created have been numeric objects. That is to say, they've essentially just been numbers. But R has other types of objects as well. So for instance, another common type of object is something called the character object, or you'll hear many people refer to these as character strings. And these get defined just by using quotation marks at each end of the value. So if we type something like X arrow, put some quotation marks, say something like spam. And if we run that, you can see it quite naturally outputs a value of spam. And in this case, we've used double quotation marks, but we don't need to use double quotation marks. You could use single quotation marks as well. So we could say Y, single quotation marks, and then type spam. And you'll find that works just as well. What you can't do is you can't mix and match the quotation marks. So if you do that and you attempt to run the code, what you'll find is your console will sort of get stuck in a kind of loop that constantly expects some additional piece of code. So I can kind of demonstrate this for you. So if we type Z arrow, put maybe a double quotation marks, I'll say spam, and then a single quotation mark, and we run that, watch what happens to the console. So you'll notice you can see this plus sign here. And this plus sign indicates that the console is expecting, some additional input to finish the line that we've written here. So the console realizes that, hey, we're not done yet. We need to kind of close this off. So if something like this happens, what you can do is you can just hit the escape key on your keyboard, and that will exit out of there. And what you're going to want to do is you're going to want to make sure you fix this mistake, like so. Now, something that'll probably seem obvious to many of you is that you can't perform standard mathematical operations on character objects. So if we try and do that, what you'll find is we'll just end up generating errors. So if we say like y times, whoops, let's do lowercase here, y times 5, for instance. If we try and run that, you can see we just get an error. Correspondingly, if we type something like 2 plus quotation marks 2, and we run that, we also get an error. Now, there is another type of object, and it's what's called a logical object. So let's maybe just get rid of all that. So a logical object is one that contains just a value of true or false. And in kind of programming discourse, you'll often hear these referred to as Boolean objects. So as an example, we could type X, arrow, and then all uppercase, just simply type true. And then we could type, Y, and then all uppercase, we could type false. And you can run both those lines. And if you look at what they output, they quite straightforwardly just output true and false respectively. And it's worth noting that the values true and false here need to be typed completely uppercase without quotations in order for R to recognize them as a logical object. If you don't do this, R is just going to throw an error in your face. So we can kind of demonstrate that. So if I type Z here, and I type true, but I only uppercase the first letter, or only capitalize the first letter, I should say, and I run that, you can see we just get an error. And it's also worth emphasizing that, typing true in quotation marks is not the same thing as typing true without quotation marks. And we can actually demonstrate this by just simply asking R what type of object something is. So what we could do is we could create two new objects. So we'll create one named A here. And A, we will type true inside quotation marks. And we'll create another object named B, and B will just be true without quotation marks, like that. So run both of those, you can see they both worked. But now what we can do is we can ask R what types of object these are. And the way you do that is by just typing a function called typeOf and inserting the object name. So you can see when we do that, R is telling us that the object named A is a character object. If we do the same thing for B, typeOf B, that is a logical object. Now it's perhaps worth knowing that R does permit a kind of shorthand version of the logical true and false values. So instead of typing true, for instance, what we could type is just an uppercase T, and instead of typing false, we could just type an uppercase F. And both of those, you can see, work just fine. Though for ease of reading, using this shorthand version is not something I'd typically recommend. It's usually much easier to read, the full word true there. In a similar vein, though, if we put a number in between quotation marks, it too will also be understood as a character object, similar to kind of what happened right there. So we create an object named C here, and we put the number like 666 in quotation marks. And we create another object, D, and we just have this without quotation marks. And you run both of those, and then you use your typeOf function. So typeOf, and we insert C here. You can see C is a character object. Whereas if we type D, that's telling us it's a double. So a double here just refers to a type of numeric value. So in R, numbers can be either doubles or integers. In this case, while we've technically typed an integer, R understands it as something called a double. That just means it's a number that uses floating point arithmetic to kind of handle number crunching. Now, thus far, we've discussed three different types of objects. We've seen numeric objects, character objects, and logical objects. But these are not the only objects that R has. And kind of as we progress through these videos, we'll learn about some others.